Hello again, everybody. This is going to be the lecture for applying solubility rules. So you should have already watched the solubility rules lecture. If you have not and you haven't kind of already worked through a little bit of that worksheet involving solubility rules, I would recommend doing that before you watch this video. Now, the main place that we apply solubility rules is, at least for this class, is when we're doing net ionic equations. These are kind of similar to half reactions that we did back in redox, but instead of focusing on where electrons are going, we are going to focus on what parts actually change. We're going to kind of just cut through all of the stuff and say, let's ignore everything that doesn't do anything cool. We only want to know, does something do anything that's interesting? And if it is, we'll talk about that. And if there's nothing that does anything cool, then we just won't talk about it. It's not really worth it. By the way, I have been trying to adjust my mic a little bit. If you do think that I'm coming across way too loud or anything like that, please let me know so I can try to adjust that and make sure it doesn't happen anymore. Okay, got our pointer, got everything good. Okay, so these problems are useful when you deal with double replacement problems in particular. Honestly, you're really only going to ever use them for double replacement reactions in my class, and I don't even think there's really there's not very many good ways to do I guess you could use it for single replacement. Double replacement is really the only time that you're really going to use this. Now, you might remember that in Gen Chem, single replacement had the option of no reaction if there was no replacement that occurred. So that's based on the activity series. Something like sodium, if it was already in a compound, is probably going to stay in that compound if it's reacting with something like silver. Silver is very unreactive. So if silver tried to displace sodium in sodium chloride, the sodium is going to be like, no, I'm way more reactive than you. I'm not going to let that happen. Chlorine's mine and will always be mine, at least as long as no one like that potassium or lithium comes along, those, crazy reactive people. Other reactions we just said, well, they always occur. They happen every time. Of course, as you used to at this point, finding out that science was lying to you, this is not actually the case. And this is one that some of you might have actually been able to predict. I know that some of the kids in my Gen Chem right now have already predicted it, where they go, so are you telling me that everything just always happens? Like, we know that when we mix certain chemicals together, there's nothing that's actually, noticeable occurring. So how can you say that there's no reaction? Also, my cat's crying in the background. I don't know if you guys can hear that. Oh, now she's nervous to be on mic. Okay. Anyway, moving on. While you can mix two compounds together and they are technically existing in the same solution, that doesn't really seem to cut it as far as it's actually reacting. Existing next to someone does not mean that you are in a reaction with them. It's like someone who sits next to you in class all year and then they think that you're dating by the end. No, that's not how that works. You have to put a little more into it than just existing next to someone. Although some guys may need to take note of that, of existing next to someone is not enough to get someone to like you. So we actually need to dig deeper into the double replacements and actually identify them as a no reaction. We want to figure out, well, does nothing technically happen? Are they just existing next to each other? A no reaction just implies that all reactions or all species or all elements that are in it remain aqueous. And remember, aqueous means dissolved in liquid. And we just figured out a whole bunch of rules that tell us if something will dissolve or won't dissolve. So we can use those rules and figure out, well, if there's a certain combination of stuff, they should make something that might fall out of the solution. It might turn into a solid and no longer be aqueous. And that, chemically speaking, is interesting. So we care about that. As a reminder, aqueous is a substance considered, or a substance is considered aqueous if the particles of the substance are dissolved in water. So if you put salt in water, the Na and the Cl, the Na plus, the Cl minus become aqueous. So how do we figure out if it's aqueous or not? Well, solubility rules. So this is going to be, I'm going to read this steps by step here, but I'm going to be working out most of these problems with a hand cam on paper, so it'll hopefully make more sense there. So your step one is to set up your full balanced equation, use your solubility rules to assign a state of matter to each species, and if something is insoluble, you're done. You just get to stop. If something won't dissolve in water, you're just going to put it in water and it's going to do nothing. I would be like me asking you to do an experiment where you drop put a straw in a cup. The straw doesn't do anything cool. It just goes into the cup. So that would be a no reaction. Those will obviously be your favorite because if even if one of the species cannot dissolve, there's no chance for chemistry to take place because they're not even existing next to each other. Step 2, if there is a reaction, you rewrite the equation. This is going to be your second line. These are all going to be in kind of 3 lines worth of stuff. Rewrite the equation, separating each aqueous substance into its individual ions. That includes the state and the charge. And then keep any other states of matter intact. So if it's aqueous, you will split it apart. And if it's not aqueous, so if it's a solid, a liquid, or a gas, solid would really just be it was insoluble. Gas, you're not really going to see. Liquid would be water. If it makes water, you can do the little cursive L for water, if you remember that from last chapter. And then step 3 is you then just cancel everything that's present in exactly the same way on each side. So it is the same thing, the same charge, the same amount, and the same state. If they all cancel, then there's also no reaction. Then even though they both dissolved, nothing cool happens, so you just call it a no reaction. But if there was a combination of things that turned out to be solid, that turned out to be insoluble, or it made water, even though you can't really see the water, we will call that interesting. That is something that actually occurred and is going on in the reaction. So here's going to be the 3 examples that I'm going to work out. This worksheet, you're probably not going to actually be able to type and complete because it would be the biggest pain in the butt. Like, it would be so unreasonable for me to ask you to type these out because writing them out is going to be annoying. Whenever you have to write out every single piece, separate it out with the charge, with the state, with the amount, like it's going to be a huge pain to do that, even in writing. So I'm probably going to make a question next Monday maybe about having you type out one of them in there or take a picture or something like that. I don't know. I haven't figured it out for sure yet. But I wouldn't expect there to be a worksheet where you actually like type them out. I might do one where you just type in like no reaction, or no reaction at the beginning, no reaction at the end, or full reaction. I don't know. We'll see. I'll come up with something. We're flying by the seat of our pants here. I do just want to remind you that if you are listening to this, today should be Friday the 20th, if you're listening to it the first time. This is the day that you should be turning in your solubility worksheet. So for that one, everything should have just been typed in the boxes. So along with this daily guide, you should go ahead and turn in that worksheet as well. Okay, I'm going to go ahead and cut this off here. There should be a second video below this where I'll be in a hand cam so you can actually see me hopefully work out these example problems. Hope you guys are having a good time so far with your, quote, quarantication, end quote. So see you guys soon, hopefully, and if not, hear from you soon, hopefully.